to another episode of Doodling Through Education. Today we have a science episode. So the last science episode we talked about Newton's first law of motion, and in this science episode we're going to talk about Newton's second law of motion. So let's go ahead and just jump in and start doodling. Newton's second law of motion states that force equals mass times acceleration, or F equals ma. Let's first define each of these terms. First, force is generally defined as the magnitude and direction that something acts on something else. This can be a push or a pull. We'll talk a little more about this later. Acceleration is the increase in the rate of speed of something, and mass is the amount of matter in a particular object. Now, remember from last week, Newton's first law of motion states that an object at rest will stay at rest and an object in motion will stay in motion, unless acted upon by an outside force. So, what happens if there is that force? Well, that's where Newton's second law of motion comes into play. So let's come back and look at our equation. Force equals mass times acceleration. Using this equation, we can see that heavier objects will require more force to accelerate, and lighter objects will require less force to accelerate, which is why we often use tools to help us move heavy and large things, like in this picture. It helps us use less force. We can even rearrange our equation to be acceleration equals force over mass to analyze this even further and determine the acceleration of an object. So let's go ahead and look at some examples. What would need a force with a greater magnitude to accelerate? A feather or a covered wagon? That's right, a covered wagon. This is due to the greater mass of the covered wagon compared to the feather. Okay, let's do another one. What would need a force with a greater magnitude to accelerate? A paperclip or a giant boulder? That's right, a giant boulder, because it has a greater mass. Now, it's important to note that force is a vector. What is a vector, you ask? Well, a vector has magnitude and direction. So force is described by its magnitude, or how much is being applied, as well as the direction in which it is being applied as well. In the real world, there are often multiple forces being applied to an object, like gravity, friction, and whatever is doing the pushing or pulling. So we must use the net force in this equation, F equals ma. To get the net force, we must add up all the forces. And remember, force is a vector, so it doesn't just measure magnitude, it measures direction. So this will tell us the direction of the acceleration as well. Okay, so now we know all this information. Let's talk about one final example to further our understanding. When NASA launches a rocket into space, during the launch, the rocket is using fuel to maintain its acceleration. So as the fuel is used, the mass of the rocket goes down. What do you think will happen to the force required to keep its acceleration the same? Yes, that's right. The force required will increasingly get less as the fuel is used due to the decrease in mass. And that's all for today. It was just a short video to help us to understand this second law of motion, Newton's second law of motion, which remember is force equals ma. Try and find an example of this at home and how you would apply this. What's doing the force? What's the mass? And how would we find acceleration? Talk with your parents about this and see if you can come up with an example this week. And on that note, remember to be kind, follow God's will, and take care. Bye.